Let's look at the problem that involving more than one technique to find the antiderivative. For number 3, we have the integral of the cosine x divided by sine square x plus sine x minus 30. We're going to use the u sub technique combined with the partial fraction technique. Let u be sine x. The differential u is cosine x dx. We place it into the integration. The cosine x dx, that is du, divided by u squared plus u minus 30. Now we have the rational integrand, which is 1 over and factor completely to get u minus 5 times u plus 6 with respect to u. As we see, this is the linear factor of the power 1 each, so we have two partial fractions. The first one with the denominator u minus 5, the second one with the denominator u plus 6. We are going to find the numerator a and numerator b. On the side, for the original rational, which is 1 divided by u minus 5 times u plus 6, equals the sum of the two partial fractions a over u minus 5 and b over u plus 6. Combine the two partial fractions with the same denominator or the common denominator. Multiply a by u plus 6. Multiply b by u minus 5 equals the left expression, which is the original rational function form. The left numerator equals the right numerator. And then choose the numbers to find a and b. Let u be the value 5. The left hand side is 1. The right hand side gonna be 11 times a, or a equals 1 over 11. For u equals negative 6, the left hand side is 1. The right hand side is negative 11b, or b equals negative 1 over 11. Bring it back into the antiderivative form. So the integral, the a is 1 over 11 over u minus 5 plus negative 1 over 11 over u plus 6 with respect to u. Both of them have the common factor 1 over 11. And then we're going to find the antiderivative of 1 over u minus 5 minus 1 over u plus 6 with respect to u. The antiderivative of the 1 over u minus 5 is natural log absolute value u minus 5. The second one is natural log absolute value of u plus 6 with a negative sign in the front and then plus c. Since log of the difference of the two logs is the same as the natural log of the quotient, so we have log of u minus 5 divided by u plus 6 and then plus c. Recall the u is the sine x. Replace it one more time to get the final result. Now we have 1 over 11 times natural log of the absolute value sine x minus 5 divided by sine x plus 6 plus c. Similar case, we are going to use the combination of the u sub and the partial fraction technique. This problem, we have the integral of 1 over e to the x plus e to the 2x. Let u be e to the x, so the du is e to the x dx. Recall u is e to the x, that means the dx is 1 over e to the x times du, which is the same as 1 over u times du. Replace it into the original integrand. 1 over the e to the x, which is the u, e to the 2x, this is the e to the x to the second power. That means we have u to the second. And our dx in the terms of u is 1 over u du. Now we have the integral of 1 over u plus u squared multiplied by u with respect to u. We can factor the denominator a little bit more. For u plus u squared, that is u multiplied by 1 plus u. U and u, that is u squared. Now we rewrite the denominator as u squared multiplied by 1 plus u. The numerator is 1 with respect to u. Now we have linear factor with the degree 2 and the linear factor with the degree 1. We're going to have 3 partial fractions. The first one with the denominator u, the second with the denominator u squared, and the last one with the denominator 1 plus u. All of them are linear. The numerator gonna be the constant term. Let it be a, b, and c. To find a, b, and c, we're gonna set up the similar way. Original fraction, which is 1 over u squared times 1 plus u, equals the sum of all 3 partial fractions. A over u plus b over u squared plus c over 1 plus u. Combine the 3 fractions using the common denominator u squared times 1 plus u. We multiply a with u and 1 plus u, multiply b by the factor 1 plus u, and multiply c by u squared, equals 1 over u squared times 1 plus u. The left numerator equals the right numerator. So 1 equals a times u times 1 plus u, plus b times 1 plus u, plus c times u squared. Pick the convenient numbers again. For example, for u equals 0, the left-hand side is 1. The right-hand side give us 1 times b, or just the b value. Now we have b equals 1. For u equals negative 1, the left is 1. The right-hand side, the a term is gone, the b term is gone. To give you the value c, c equals 1. Next, pick another easy number. For example, if u equals 1, the left-hand side is still 1. The right-hand side gonna be 2 times a plus 2 times b plus the c. Since c is 1, b is 1, we have 1 equals 2a plus 2 plus 1, or 2a equals negative 2. That gives us a equals negative 1. Bring it back to the integrand. Now we have the integral of negative 1 over u plus 1 over u squared, and the c is 1, so plus 1 over 1 plus u, all with respect to u. For the antiderivative, again, 1 over u squared, just be careful, this is u to the negative second. The antiderivative of negative 1 over u is negative natural log absolute value of u. The antiderivative of u to the negative second is u to the negative first over negative 1, plus the last antiderivative, which is the natural log of absolute value of 1 plus u, and then plus c. Since u is e to the x, we're going to bring it back into the problem. Now we have negative natural log e to the x. E to the x always positive. We can omit the absolute value. And u to the negative first divided by negative 1 is negative 1 over u. Then we get negative 1 over e to the x plus the natural log of 1 plus e to the x, and then plus c. For the natural log of e to the x, this is x. Simplify one more time. So we have negative x minus 1 over e to the x plus the natural log of 1 plus e to the x plus c.